Hi, mining community. Welcome back to another episode of the Dig Deep, the Mining Podcast. And today's guest is Richard Papp, who's the Managing Director at UNEXMIN Geo-Robotics, who are a private spin-off company arising from U-NEX-MIN project. And they have their IPO of the robotic platform they have produced. The company are pioneers in surveying solutions for flooded environments. And Richard, who has a background in geology and geophysics, is going to talk to us about the exciting and innovative advances they are making in geo-robotics and how this can be used in the mining sector. So that's welcome Richard to the podcast. How you doing, Richard?
Thank you. Fine, I'm good. And you?
Yes, I'm good, thanks. It's a Friday, so it's the end of the week. So really appreciate you coming onto the podcast, and obviously we want to hear more about the exciting things that you're doing in robotics. So before we start, I wondered if you can give us a little bit of background about yourself and tell us a little bit about the company as well.
Okay, so first of all, thank you for the invitation. It's a nice opportunity for us to introduce the company and of course myself, but it's, it's just a secondary thing. So as you mentioned, I'm a geologist and geophysicist, and I'm just finishing my PhD in mineralogy, in applied mineralogy. And besides that, I started to work on the U-NEX-MIN project and later the U-NEX-MIN project just to build and develop a nice new robotic solution for underground mining explorations. And of course, I started to work for the UNEXMIN Geo-Robotics company just a few months ago, but I'm more in the topic for more than 5 years now. And just a short introduction about the UNEXMIN Geo-Robotics company. So as you mentioned, this is just a spin-off company which based on one of the Horizon 2020 project that was finished in 2019, and we are commercializing our technology that was developed during this first project, this U-NEX-MIN project, from 2018. So basically, this company is just making the marketing and of course planning the pilots and making the commercialization tasks for the underwater robotic surveys.
Yeah. First question I want to ask is, how did you get into this?
During my master degree, my supervisor was involved to this project. Actually, he is the project manager of the U-NEX-MIN project and the continuous project, the U-NEX-MIN project, and he involved me to the work. So previously, I worked lots of different kind of instruments, such like X-ray fluorescence spectroscopy, electron microprobe analysis, electron microscopy, and so on. And based on my background, he asked me to help for the team to develop the different scientific instrumentation for the robots.
Okay. Can you just tell us a little bit about how UNEXMIN Geo-Robotics, how it was established and how the company has grown over the last few years?
As I mentioned, it was established in 2018. This was one of the requirements of the U-NEX-MIN project. So when we won the tender, the proposal from the Horizon 2020 programs, one of the main requirements was to make a small company, to be able to commercialize all of the technologies that we developed during this 5 years long project. And when the project was finished, we applied for another project from the EIT raw materials program, and within this program we are developing and upscaling the original robots and the original solutions, and this project was started in 2012. So you can feel that this company was just finished, was just one of the requirements of the original project, and we made a lot of improvement, and we started to make the commercialization and starting to grow the company. And from the last year, we are really just on the way, and we are really commercializing. We are really planning the future of the company, and short and long term plans are developed, business portfolio, and so on. So this is the short story of the company, and of course lots of things to do right now. But yeah, this is how we started the company and how was it started as an SME.
Yeah. So what's the aim of UNEXMIN and U-NEX-UP projects? Obviously, that the company involved in.
Yes. So the UNEXMIN project, that was the first project that I mentioned. The name of this project is coming from the underwater explorer for flooded mines. And if you are merging it, it will be the UNEXMIN. The aim of the project was to build a robotic solution, a submersible or submarine, which can be deployed in different flooded mines and explore what is the remnant of the mine, what was buried in the mine, or what left under the flooded environments. The main reason and the main capability of this solution, or maybe this project, is just in the European Union there are almost 30,000 mines which was closed, and some of them are, or not just some of them, but thousands of them is flooded. And usually, probably you know that when a mine is closed, then it's not depleted. It's just not efficient. I mean, from financial background or financial part, it's not efficient to mine anymore. But when the technology is upscaling and the technology is growing, we have new solutions, we have new possibilities to reach the ore what was left there, and of course the prices of the raw materials are growing and growing, and because of these mines are flooded, they are not easy to access to the mines, and most of the mine is really deep. So from few hundreds of meters till thousands of meters, or 2,000 or 3,000 meter deep can be a mine, and there is no, or there was no technology to explore the actual mine. And as I mentioned, we finished this project in 2018, and during the UNEXMIN project, we built 3 prototypes of the robots. These prototypes were tested in different mines, different environments, caves, and so on. And we feel that we can improve it, and we can make new technologies, new possibilities for the robot. We can make better solution for example, for the pressure resistance. And we just started our new project called U-NEX-UP in the beginning of the last year, so in 2020. And right now we have 1 robot which is ready, and it's already tested and already explored some mines and caves in Europe, and we already started to commercialize the technology. So this is the background, and this was the aim of the project, just to be able to explore those flooded mines what was not available with the technology of the recent days.
Yeah, obviously you mentioned there was 30 mines across the world that are flooded. Is there particular countries or particular continents where a lot of these underground mines are? Is there a concentration, or is it really across the whole world?
It's across the whole world. So, of course, there are places like Europe when most of the mines are just closed, and we are really focusing on the European continent, because this is the most easiest to the company to reach. But we have some interest from, for example, from Canada, from Brazil, so actually from all over the world. It's only depending on what we can do with the robot, and of course how complex is a mine, how deep is a mine, because there are some technological barriers that we are just planning to cross or planning to break. But of course there are limitations of our robot also.
Yeah. So obviously, talking about the robot, what are the capabilities of the actual robot, and where did you test these?
It's a really nice question. So in the first project, in the UNEXMIN project, we built 3 prototypes, and these 3 prototypes were able to reach the 500-meter water depth, which is practically in fresh water that is 50 bars. And I will explain why I'm talking about bars, so pressure, not only the water depth, because it's always changing and it's always depending on the environment. But yeah, firstly, we made a robot which can reach this 500 meters, or not just one, but 3 robots which can reach the 500 meters. And during our new project, during the UNEXMIN project, we developed a really similar technology to this one. So our recent robot is also dedicated up to 500 meter or up to 50 bars of pressure, but we are planning to improve it highly. So we are planning to improve it to 1,500 meters water depth, which is really feasible for mining exploration, because most of the mines are really deep, and this 1,500 meter is it's really complex thing to build and able to use the robot at that level. And other thing is what is really important in the case of robots is it's able to use or able to move in any directions. It has 6 degrees of freedom, so we can go up and down, sides, back, forwards, and we can rotate the robot, and we can even tilt the robot. So if you would like to go see down, then we can do it with all of the 6 cameras which are installed to the robot, and of course we can do it when we are tilting the robot. It's important because you know that the mines are really complex areas and really complex environments, and if it's just closed, for example, due to flood, so water income, then lots of wires, I mean metal wires, and maybe metal bars or wooden bars, falling rocks, and everything can be left there, and we would like to see everything because we are hovering to lose the robot. These are not so cheap technologies, and just to able to navigate under the water, we are using different navigational systems. For example, an IMU, which is a inertial moving unit. So we are able to check the movement of the robot just with the inbuilt unit. And of course, we are using active navigational technologies like sonars and laser scanners. And with the help of these scanners and sonars, we are building 3D maps, actual 3D maps from the mine, with the resolution of just a few centimeters. So from 1 to 5 centimeters is always depending on the water quality and how far we are from the walls or in the shaft. And one of the most important thing is probably the mass of the robot, the weight of the robot, because the first robots were more than 110 kilograms, and it's not easy to carry. So it need at least 4 people to carry the robot. Our new robot is less than 90 kilograms, which is a huge improvement in case of miniaturization and other kind of technologies. And one other really important thing is the diameter, because if we are going to really tight areas in the mine, really tight corridors, really tight shafts, then there is a maximum diameter what can be used. And the original robot was 60 centimeters in diameter, and our new robot is a little bit bigger due to the new scientific instrumentation, but it's like 70 centimeters times 60 centimeters. So it's not so much bigger, but at least the weight is less with more than 20 kilograms. For the robotic exploration, we are not using cabling for power the robot. There are inbuilt batteries, and these batteries can stand for hours underwater. The only connection with the surface is an optical cable, is an optical wire, but we are using this just to get the necessary imaging from the environment. So we have visual contact with the robot and visual visual information from all of the 6 cameras, and we can decide where to go with the robot and where to turn, where to stop a little bit. And of course, it's much more easy to avoid any of the collisions and any of the obstacles underwater or in the shafts. And the other question was where we tested the robot. And during the first project, during the UNEXMIN project, we made different tests, different pilots with the original robot. The first one was in Finland, in Katjala, which is an open pit mine, an open pit pegmatite mine. It's flooded, and it's really nice caving place. So lots of cavers were, lots of divers were there, and we made 3D imaging about some tunnels which was connected to the bottom of the lake. The other test site was an old and not abandoned but closed mercury mine in Idrija in Slovenia. That mine is a World Heritage place, and we just dived with the robot and checked all the side tunnels and everything what was underwater and what was reachable with the robot. And there were 2 other places that we visited during the first project. The one, sorry, not 2 but 3. One of them was the Urgeirissa uranium mine in Portugal, and you can feel that in a uranium mine, no divers are available to explore the mine. So it's really also an important thing. We can do that kind of environments with the robots where nobody can dive due to the health issues and everything. The fourth mission was in the United Kingdom in the Acton mine, which was a copper mine, and it was closed 150 years ago, so 150 years ago. And we made lots of dives and tens of hours in the water and make really nice images and really nice maps and geological investigation about the abandoned shaft. And the last mission during the original project was an outlier because it was not a mine. It was a cave in Budapest, in the Molnár János cave in Hungary, and that cave is just a diving place, and it's a thermal cave with thermal water, with the water temperature like 20 or 22 Celsius degrees, and lots of divers are available there, and we use that cave to see what are the exact capabilities of the robot. How far can we go? How fast can we go? How detailed can be the map? And in our new project, in the UNEXMIN project, we visited again the Urgeirissa mine, the uranium mine in Portugal, because we can compare the 2 robots. We can compare the old robots and the new robot. And also visited the Molnár János cave, just for the same reason, just to be able to compare the results of the old map and the new maps. And after that, we visited the Csor water well in Hungary. And this is also such kind of outlier, but it was a semi-commercial job for the company. And they ordered visual inspection and 3D map, really accurate 3D map from the water well, which is a fresh water well and used to pump fresh water for the nearby towns. And the last place what we visited was in Ukraine, was in Solotvino. It is an abandoned, or not abandoned, but closed salt mine with really salty water. And this is where I would like to connect to the original problematic with the water depth and the pressure, because in this mine we reach that level of the water when the solubility or the solution, because it was not just the water, it was a solution, was actually oversaturated with salt. And the density of the water was not 1, but it was 1.55 cubic centimeters per gram per cubic centimeters. And that means the density was 1/4 higher than in normal condition. And when we are going down with the robot in this kind of environments, then the pressure will increase much highly or much faster than in a normal fresh water. And this is why we are saying that our robot is able to dive down to 50 bars, because if we are diving in this kind of environments, then of course we are not able to reach the 500 meter, but like like 420 or 450 meters, depending on of course, the solubility and the density of the water.
Okay, so you've obviously tested the robot out quite a few times there, as you've explained. How will these robots help mining companies, and what challenges would they be faced with when they obviously use your product? Obviously, from what you've been saying, obviously automatically you think of just underground mines, but it seems the robot can also be used for open pit mines as well. So yeah, so I just wondered how this will help mining companies if they looked at your product.
Yeah, actually, this robot was built for underground mining or flooded underground mines. But of course, as you mentioned, we can use it in open pits. The designing of the robot was not exactly for the open pit mines, but we can do almost everything on open pit mines. So profiling, water chemistry measurements, water sample collecting, and we have a bunch of different scientific instruments on board. So firstly, and most of the interest of the market is on the mapping of the mine. So we just have an actual 3D map and a really precise 3D map, because when somebody would like to reopen a mine or open a mine next to the old mining area, and they are starting to drill, they usually wants to avoid to cross the old mining places, so the old corridors and the old chambers. So this is the first thing what the market is interesting on our technology, the 3D mapping. And of course, with the help of the scientific instrumentation and with the help of the video cameras, we are able to make photogrammetry, and we are able to make geological investigations. So just based on the images and based on the scientific data that we collected, we can make really nice 3D model about the actual geology of the mining site, because we can see and we can navigate precisely underwater. We know always the position of the robot, and just based on the features that you can saw in the mine walls or in the walls of the corridor or on the top or whatever, we can make really nice and really detailed geological maps, which is sometimes are not available, because if a mine was closed in not just 50 years, but maybe 100 years ago or 80 years ago, sometimes the documentation is lost or destroyed in a fire, or anything can happen, and we can help a lot just to know what is left under the surface. And of course, we have an instrumentation to check the remnants of the minerals underwater. So with the so-called multispectral hyperspectral camera, we are able to detect what kind of minerals left in the mine corridors, and with the help of this, we can expect what is left over in the mine.
Okay. Which environments can the robot be used? And obviously, how many people does it take to operate?
As I mentioned, we can use the robot in freshwater, and of course in seawater, and even in the oversaturated salty water. So actually, there is no limitation to use the robot. The only limitation can be the temperature of the water. So we are not able to use it in almost boiling water. So above, let's say above 60 or 70 Celsius degrees, because of the heating, because of the cooling of the computers built inside the robot. So we are using the frame of the robot to cool the computers, and if it's too hot, the outside environment, then we are not able to use it. But actually, if there is any entrance, any big entrance to deploy a robot, then we can use it and we can survey with it. And how many operators are necessary? Right now, we are under development, and now 3 or 4 people are needed to operate the robot. This is because it's still heavy, so it's still almost 90 kilograms, and if you want to carry it, then 1 people is not enough to do it. And because of the of the development, just for safety reasons, we are using or 4 people are necessary to see the cameras, check the condition of the robot, and check everything. But from practical point of view, only 2 people is enough to deploy a robot and use the robot. So maximum 1 extra person is needed to help to lift the robot. But if we are using the proper equipments, then it's not necessary. So if there is a forklift available or a proper winch or pulleys, then only 1 person can lift the robot and release it. But of course, for safety reasons, at least 2 people are necessary to use it, because anything can happen, and we don't want to lose the robot. And of course, more eyes can see more. So this is why the 2 people will always necessary to use it.
Yeah, certainly. And what's the deepest dive the robot can go to? And also, how long do you recommend that the robot stays underwater? I mean, is there a particular time limit that the robot can stay underwater for?
How deep was our deepest dive is 306 meters. That was the deepest dive till now. But all of the equipments that building the robot, and our new robot is a modular robot, so we can release all the cameras, all the different kind of cylinders and everything. And all of these equipments are tested to reach the 1.5 kilometers. Just this robot, for safety reasons, we are using or we are planning to use for 500 meters, but all of the equipments were successfully, and this is the important thing, but it was successfully tested till 150 bars. Let's say that. And so yeah, that was your other question.
Yeah, the other question is how long can the robot stay underwater for? Is there sort of a time limit?
Yes, it's depending on the charges of the batteries. So we are using 2 batteries, and we can use the robot up to 5 or 6 hours underwater. It's really depending on the usage. So if we have to go fast, and we have to use the thrusters and the instrumentation in an inefficient way, then it's only, let's say only 4 hours. But if we are saving the batteries, then it can be used at least for 6 hours. Yeah, usually it's, of course, is depending on how much we would like to use the batteries. So for safety reasons, we are not using only till the 20% charging of the batteries. But of course, if it's needed, if it's really needed, then we can lower it and we can use it for almost only 1% of charging of the batteries. But this is not the right thing to do.
Yeah, and also, is the picture beamed back to obviously a phone or computer in real time, or do you obviously you record all of the visual, and obviously you can replay that back later? Is everything done in real time?
Everything is done in real time, so we can see all of the 3D maps or 3D point cloud what the robot is building, and all of the videos what is captured during the dive. But of course, everything is recorded for post-processing. We are using optical cable, as I mentioned, for the fast response time from the robot, so we can see actually the best quality videos during the dive. And because of this cable, there is some limitations of the robot. So the limitation is always the length of the cable. But because this is just an optical cable, we can attach just a few meters of cable and even kilometers of cable. So usually the cable is not a limitation. The battery is the limitation, because of course we can use the robot till 6 hours, but the robot should go 3 hours on one way and 3 hours on the back. So this is the actual limitation of the robot. And during these 6 hours, we have real life connection with the robot, and we can see everything what we want. And of course, if there is any kind of problem, then we can avoid it, and we can for example, we can stop for a detailed measurements and detailed scanning in a certain area. And another important thing is when we are collecting, for example, water samples, then we can see the exact position of the robot, and we can decide where to take the water sample, because it's an important thing. And of course, if there is the company who are interested on the water samples, they can show us the place where we should collect the sample.
Okay. And as a conclusion, how is the next 12 to 18 months looking for you guys?
First of all, we would like to make our first real commercial job, I mean fully commercial job, and we have some plans, but it's let's say it's confidential for now. And we are building on our next robot. So now we are using the robot so-called UX1 Neo. This is the new version of the UNEXMIN robots, and we are planning and we are already developing and building the second robot, which is the UX2 Deep robot. And this is for this robot will be built to be able to reach this 1,500 meter water depth and some new scientific instrumentation, for example, a rock sampling unit, because this should be probably one of the most important things for a customer, to be able to collect real samples from a wall, from a sediment, or from any kind of places under the water. And this is what we are facing for. It looks like the second robot will be ready in the beginning of the next year, or in the first quarter of the next year. It's always depending on the real situation. So probably you know that, or you heard about that, the supplies, or I mean the raw material supplies, is limited due to the COVID. So it's not easy to buy the components for the robot, but it looks like we will be finished in a few months, and we are really going further for the commercial job and jobs and making the marketing.
Yeah, Richard, really appreciate your time in telling us and telling the audience about obviously this new product, and obviously it's an important part if you, I suppose, whether even if you're a mining company that already has an operating mine, or you could be a company that is looking and prospecting obviously new mines that haven't been in operation for quite a few years. So I suppose this product will appeal to quite a few different range of people. So if our audience wants to reach out to you, how can they go about doing that? Find out some obviously more information, and are you on any social media platforms?
Yes, we are on LinkedIn, and we have, of course, our own website, and what else we have? Yes, Facebook pages, and maybe practically, you know, all of the different kinds of social media the company can be found. Yeah,
no worries. And what I'll do is I'll include those in the show notes accompanying this obviously podcast, so they can reach out to you if they've got any questions. I'm sure quite a few of our listeners would have been in those situations where they wanted some extra data in some sort of deep water, and maybe not being able to do that, and obviously now you have a solution to give them. So really appreciate your time, Richard. Those that are listening, appreciate if you can share this episode amongst obviously other people within the industry, because you never know who may need this product, who may be in a challenging environment, and obviously this product could obviously help them solve their challenges. So really appreciate your time for listening. Thank you again, Richard. And until next time, happy mining.